simple machines are fundamental tools that make our work easier by multiplying force. In this video, we'll explore mechanical advantage and understand how three basic machines, levers, pulleys, and inclined planes, help us accomplish tasks that would otherwise be impossible with our bare hands. These principles form the foundation of nearly every mechanical system we use today. Mechanical advantage is the ratio of output force to input force. In simpler terms, it tells us how much a machine multiplies the effort we put in. The formula is MA equals F out divided by F in. For example, if a machine has a mechanical advantage of 5, it means the output force is 5 times greater than the input force. This allows us to move heavy objects or overcome large resistances with relatively little effort. A lever is a rigid bar that rotates around a fixed point. Every lever has 3 key components. First, the fulcrum, which is the pivot point around which the lever rotates. Second, the effort, which is the input force you apply. And third, the load, which is the output force that moves the object. By changing the position of these 3 components, we can create different types of levers with different mechanical advantages. Levers are divided into 3 classes based on the arrangement of the fulcrum, effort, and load. Class 1 levers have the fulcrum in the middle, like a seesaw, crowbar, or scissors. Class 2 levers have the load in the middle, such as a wheelbarrow, nutcracker, or bottle opener. Class 3 levers have the effort in the middle, like tweezers, a fishing rod, or the human arm. Each class serves different purposes and provides different mechanical advantages. The mechanical advantage of a lever is calculated using the formula MA equals D effort divided by D load. This represents the distance from the fulcrum to where you apply the effort, divided by the distance from the fulcrum to the load. For example, if you're using a crowbar where the effort arm is 1 meter and the load arm is 0.1 meters, the mechanical advantage is 1 divided by 0.1, which equals 10. This means you can lift an object with 10 times less force than would be required without the lever. A pulley is a wheel with a grooved rim around which a rope passes. Pulleys come in 2 basic types. A fixed pulley is attached to a stationary point and only changes the direction of the force, giving it a mechanical advantage of 1. A movable pulley, however, is attached to the load itself and multiplies the force, providing a mechanical advantage of 2. This means you can lift an object using half the force. When pulleys are combined into compound systems, the mechanical advantage equals the number of rope segments supporting the load. If 2 ropes support the load, the mechanical advantage is 2. With 4 ropes, the mechanical advantage is 4. With 6 ropes, it's 6. This simple counting method makes it easy to determine how much force multiplication a pulley system provides. More ropes mean less force needed, but you must pull the rope a greater distance. An inclined plane is a flat surface set at an angle to a horizontal surface. It's one of the simplest machines, yet incredibly powerful. The key concept is that less force is needed to move an object up a slope than to lift it straight up vertically. However, there's a trade-off. While you use less force, you must move the object over a longer distance along the slope. This is the fundamental principle behind ramps, roads, and even screws. The mechanical advantage of an inclined plane is calculated by dividing the length of the slope by its vertical height. The formula is MA equals length divided by height. For example, if you have a ramp that is 6 meters long and rises 2 meters high, the mechanical advantage is 6 divided by 2, which equals 3. This means you only need 1/3 of the force to push an object up the ramp compared to lifting it straight up. Let's compare the 3 simple machines. For levers, mechanical advantage is the distance to the effort divided by the distance to the load, based on the distance ratio from the fulcrum. For pulleys, mechanical advantage equals the number of ropes supporting the load. For inclined planes, it's the length of the slope divided by the height. Each machine uses a different approach, but all achieve the same goal, multiplying force to make work easier. Simple machines are everywhere in our daily lives. In construction, we use cranes with pulleys, pry bars as levers, and loading ramps as inclined planes. In everyday tools, scissors are levers, flagpoles use pulleys, and stairs are inclined planes. In transportation, car jacks are levers, elevators use pulleys, and highway ramps are inclined planes. Understanding these principles helps us recognize the physics at work all around us. Let's review the key points. Simple machines multiply force through mechanical advantage, making difficult tasks manageable. A greater mechanical advantage means less force is needed, though you must move through a greater distance. Levers, pulleys, and inclined planes all follow predictable mathematical formulas that let us calculate their effectiveness. These principles appear everywhere in technology and nature. Remember, work smarter, not harder. By understanding mechanical advantage, you can use simple machines to accomplish amazing things with minimal effort.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.